In this demo, we will take a look at a simulation model of an emergency department. We will first discuss the simulation project objectives. We will then review the process flow of the system. Next, we will take a look at the various input parameters and demonstrate how they can be adjusted. Finally, we will run several different scenarios and review output reports. By the end of the demonstration, you will have a good understanding of how to use a simulation model to analyze a process. Why simulate the emergency department? The ED is complex. There's a lot of variability and many system interactions. Consequently, it is extremely difficult to understand how changes will impact the system without using simulation. A simulation study should be conducted to identify opportunities to improve patient flow. Bottlenecks can also be studied, and ways to reduce them can be identified. Simulation will help analysts to understand the true capacity of the system. Managing resource utilizations and optimizing schedules are also key objectives. The impact of variability and how controlling processes can improve system performance can also be studied. Identify means to reduce patient waiting times. Plan for future growth strategies. There are many changes that can be made to your system. Use simulation to confidently make the right decisions during the design phase of your project. Once there is a reason for a simulation project, the next step is to understand the process flow. Let's look at the running model to understand how the system works. You will see walk-in patients arriving via car on the bottom right. If a triage nurse and registrar are available, patients will complete the registration process. If a bed is available, they will proceed to the back. When resources, beds, nurses, or registrars are not available, patients will wait in the waiting room. Patients are also arriving via ambulance on the left. The majority of these patients are rushed straight to the back. Patients will walk out of the ED if they wait too long for a resource. This is lost revenue for the hospital. Patients that reach the back will be assessed by a nurse and a physician. Patients will typically receive a combination of treatments, labs, and X-ray procedures. Patients may then be discharged or admitted to the hospital. The simulation model includes a detailed animation of the ED at different points in time. Key performance statistics can also be seen, from resource utilizations to total throughput counts to the number of patients waiting. The simulation provides key performance measures to help analysts make the best decisions. Before we run any scenarios, let's take a look at the model inputs. With this Excel interface, we can easily change the arrival rates of patients to the ED by day of week and hour of day. We can also change the number of beds available, the radiology room capacity, as well as the resource availability throughout the day. We will assume that the model is verified and validated, and the current inputs are the baseline for all scenarios. Let's run the model and take a look at the key outputs. Queuing statistics help identify bottlenecks. The queue time until a patient can get a room helps to identify issues in the waiting area. This average time is about 6.7 minutes. The longest wait is for the radiology room, with an average wait of 48 minutes. Resource utilizations provide insight into the current capacity of the system. Beds, for example, are 51% utilized. Additional user-defined statistics identify cycle times as well as throughput counts. These key performance measures are critical to compare alternative system designs. It is often useful to select several key outputs for effective comparison of alternative designs. For this example, the following statistics have been selected. Now say we want to understand if the current capacity is adequate to handle a 25% increase in the patient arrivals. Let's make the change in the user interface, run the scenario, and record the results. We can see the wait time for a bed is significantly increased. Bed and radiology room utilization is also up. How do we know what changes to the current ED are the most effective to handle the increased patient flow? We could add capacity, change process flows, improve processing times, adjust resource schedules. For this example, first we will increase the number of beds and rerun the model. Looking at the outputs, it does not appear that the increase in capacity made a big impact. In fact, the wait for an ED bed has actually increased. It looks like the radiology room is a bottleneck. What if we increase the capacity of this resource? Let's make this change and run the scenario. Again, looking at our key performance measures, it appears that this change will have a major impact on the efficiency of the system, and patients will notice a significant decrease in waiting times. This is a great start to the analysis, and now additional scenarios can be run to determine the optimal changes to the system. Thank you for taking the time to learn more about simulation today. Please visit our website to contact us and learn more.